So, the review for the test for the Pythagorean trigonometry test is here. Okay, when we're doing Pythagorean theorem, we got to remember what it is, and it's right here. A squared plus b squared equals c squared. So, remember, a and b are next to 90. C is across from 90. So 7 squared plus x squared equals 25 squared. Then we got to square these numbers. 7 squared is 49 plus x squared. Now, if you don't know what 25 squared is, that's okay. You can use your calculator. 25. And then to solve for x, we get rid of this loner 49 by subtracting it. Anytime you're missing a leg, you're going to subtract it. Missing a or b. Okay. So 625 minus 49, 576. Okay. Now it depends what they're asking for. Now there's no instructions here on what to do. But your next step is to get rid of the square with the square root. Okay. If it was simplifying radicals, then you would do the factor tree. Okay. But since it doesn't tell us, we're just going to type it in, square root of 576, 24. Okay. All right, on the next one, again, here's my right angle. So we got A, B, and C. Now, check it out. A looks like it's missing, but over here is 5, so over here is also 5. Okay, so let's do this. A squared plus B squared equals C squared. 5 squared plus 10 squared equals C squared. 25 plus 100 is C squared. So we got 125. Square root is my last step. What is the square root of 125? 11.18. Okay. Same thing here. Got A, B, and C across from 90. Now you might remember this is a Pythagorean triple, 5, 12, 13. But either way, you can still do it. A squared plus B squared equals C squared. 25 plus 144. Now I know I'm squaring these kind of fast, but you can definitely type them in the calculator. 25 plus 144 is 169. And your last step again is always to square root. The square root of 169 is 13. Okay, now you can type it in the calculator and get that, but it is 13. Okay, once again, A, B, and C. C is across from 90. So 7 squared plus 9 squared equals C squared. 49 plus 81 equals C squared. And what we get? 120, 130 equals C squared. Last step, always square root to get rid of that square. 11.40. Cool. Now those are all obviously Pythagorean theorem. This next one, if you know two sides and you're missing a third side, the height here, it's once again Pythagorean theorem. A, B, and C across from 90. 5 squared plus h squared equals 10 squared. 25 plus h squared equals 100. Once I square them, minus 25 minus 25. H squared equals 75. All right, and height, I definitely need the decimal. So to get rid of the square, we square root. What is the square root of 75? 8.66. And what were my units of measure? Meters. Okay. Now this is going to be tricky-ish, and this is going to be tricky on the test. Pole struck by lightning, broken into 2 pieces. One underline on that, 2 pieces. One piece is 12 feet, the other part fell 16 feet away. Okay, we'll call this X right here. Here's my right angle, so I'm going to label it A, B, and across is C. All right, so again, Pythagorean Theorem. 12 squared plus 16 squared equals X squared. So this is 256. This is 144. Add them up. I think you get 400. What is the square root of 400? 20. Wow. Now, is 20 the answer? We solved for X. We got 20. And that's what this piece is. But remember, what do we say right here? 2 pieces. So it's going to not only be 20, but you're also going to add the other piece. So the other piece is right here, 12. Okay, you have to add these together, 20 plus 12, which gives you 32 feet. Cool. Next. So again, that's how you do it with trig. You have to add the 2 parts, the 2 pieces at the very end to get the total of the pole that was struck by lightning to get the original height before it fell over. Okay, don't just look for the one piece that broke the whole thing. 13. Okay, don't forget Sohcahtoa Trigonometry. The angle on all these is F. So let's go ahead and put an arc at F. Label O, H, and A. And then sine, cosine, tangent. Sine is O over H. So 4 over 5. Okay, cosine is A over H. 3 over 5. And then tangent is O over A. 4 over 3. And on all these, you leave it as a reduced fraction. If they were not reduced, we would try to reduce them. Okay, but these are good. Okay. Do some more trig. The angle they gave me is 50, so I'm going to label O, H, and A. Now, the one I don't need is H. There's nothing there. So OA is TOA. So I'm going to write tan, the angle, 50, equals O over A, 17 over X. And we've learned when X is on the bottom, the trick is to take all this and switch it around with this. So X is over here, 17 stays on top, tan 50. 17 over tan 50. So 17, control divide, trig, tan 50. 14.26. Cool. All right, 17. Find the angle, label OHA. Across from 90 is H. A is left over. Which one has nothing? It's got to be A. So OH is so for sine. Sine, then the angle, 35, equals O over H, X over 26. Now, when X is on top, to get rid of a divided by 26, I do times 26 to cancel it out. And if I do it on one side, I got to do it on the other side. So it's going to be sine 35 times 26 on the other side. Let's type that in, sine 35, go to the right, times 26, and I get 14.91. Okay. All right, 18. Same thing. Here's my angle. So I label O, H, and A. O is missing. Cross it out. AH is going to be ca, so cosine 53 equals A over H, 45 over K. K's on the bottom, switcheroo. So k is equal to 45 over cosine 35. Sorry, 53. All right, 45 over cosine 53. Whee! Goodness. Okay. And in turn, you get 74.77. Cool. All right, on this section, here we go. Opposite, here's the 90. Hypotenuse, adjacent. O has nothing, so that's cosine. Cosine 60 equals a over h. X over 13. So times 13 times 13. Cosine 60 times 13. What is cosine 60 times 13? Cosine 60 to the right times 13. Get 6.5. All right. There you go. So there's 4 trig problems. How you set them up. If you look at it again, number 16 and 18, that's when you switch with the variables on the bottom. 17 and 19 is when x is on top. You got to multiply. Okay. All right. Now here's some inverse trig. So when inverse trig, use a little -1. So starting here, we'll call this x. Okay. Each of these you can call them x. They're missing. So you got O, H, A. H is missing. So we have to remember Sohcahtoa. Okay, OA is TOA, so tan x equals O over A, 21 over 25. And then remember, we move the trig to the other side. Tan goes here, but it has to be inverse. So x equals tan inverse 21 over 25. Tan inverse 21 over 25. So it's in the bottom here. 1 over 25. And I got 40.03. And since that's a missing angle, it's going to be in degrees. Again, O, H, and A. So H is missing, so OA is TOA. So once again, it's tan X equals O over A. So trig goes to the other side, inverse. X equals tan inverse 9 over 29. All right, tan inverse 9 over 29. Oops. Yeah, I don't know what's going on here. Whatever. Okay, tan inverse of 9 over 29 is 17.24 degrees. All right, last one on this section. O, H, and A. The missing side is O. So H is cosine X equals A over H, 37 over 40. Cosine goes to the other side, becomes inverse. So X equals cosine inverse 37 over 40. Cosine inverse 37 over 40. Like 22.33 degrees. All right. Last page. Okay. We're looking for a missing angle again, so we're going to label O, H, and A. H is missing, So it's going to be OA, which is TOA. So tan x equals O over A, 42 over 25. Tan moves to the other side and becomes inverse. We get tan inverse 42 over 25. Let's look at that. Tan inverse 42 over 25. We get 59.24 degrees. Okay. Again, we have a missing angle. You do inverse trig. Now, these next three are going to be super easy. You just type them in. Cosine 91. Let's try this. Negative 0.0, and we're going to round 2. Sine 24. 0.41. And tan 17. 0.31. Cool. All right, last section here. Square root of 147. We do the factor tree. Let's start with 3. 49. And then 49 is 7 times 7. Okay. And that's it. So we got one pair, one loner. So it's 7 square root of 3. Pairs go out, loners stay in. Okay. What about if there's already a coefficient? Circle that coefficient. On 60, we got 2 times 30, 2 times 15, 3 times 5. So you got a pair of 2, and outside 3. So the 2 and the 3 multiply to make 6 on the outside. And these leftover 3 and 5 multiply to make 15 on the inside. So coefficients and pairs multiply outside, loners stay inside. Okay, on 29, if you're subtracting things, you just subtract the coefficient. 8 minus 5 is 3, square root stays the same. Okay. On this one, 2 is over 1, which is 2, and then the square root can divide 12 over 4 is 3. That's it. Next one, you cannot have a square root on the bottom, so times the square root of 3 times the square root of 3. You got to multiply by the same square root on the bottom and the top. A number and a square root multiply to make this, just put them next to each other. Square root of 3 times square root of 3 removes the square root, and it's just 3. And now, the coefficients 6 and 3 can divide to make 2, and the square root of 3 stays there. All right. Last but not least, square root of 7s, those can combine. Square root of 5 does not combine. You bring it after, okay? So 8 plus 11 is 19. Square root stays the same. And then you bring down the one that's different. Next to it, you can only combine like terms. All right. That's your review.